This video introduces the topic of finding zeros. The learning outcomes are to use synthetic division to divide polynomials by x minus a, and to use the remainder theorem to determine the values of p of a, and to linearly factor polynomials using various theorems. The theorems that will help in factoring are the factor theorem that will determine if x minus a is a factor of the polynomial p of x, the rational root theorem, which helps decide possible factors for the polynomial. Before we begin factoring, let's review division, long division in particular. Let me begin by reviewing some vocabulary as well as long division of numbers. Let's divide 3,105 by 4. Setting this up, we put the dividend, 3,105, in the division symbol, and the divisor, 4, on the outside of the division symbol. Now we say 4 cannot divide 3, but will divide 31 7 times. We put the 7 on top of the division symbol and multiply. 7 times 4 is 28, and then we subtract 31 minus 28, which is 3. Then we bring down the 0. 4 divides into 30 7 times. Multiply till we get 28. Subtract and we get 2. Bring down the 5 and divide 4 into 25, which is 6. Multiply 4 times 6 to get 24. Subtract and we get 1. This 1 is the remainder, and we will have written our answer to this division problem as 776, remainder 1, to show that the quotient, the answer we get when we divide it, is 776, and the remainder is 1. Later, when we were learning how to do long division, we saw that we could write our answer as 776 1/4, where we wrote our remainder over our divisor. Notice that we can write 3,105 as a multiplication of 776 times 4 plus 1, which is our remainder, in this format, as parentheses 776 times parentheses of 4 plus 1, which is equal to 3,105. This format is the quotient, the 776, times the divisor, which is 4, plus the remainder, which is 1, which equals to our dividend, which was the 3,105. Let's use long division on polynomials. Let's divide 3x cubed minus x squared minus 150 by x minus 4. Our dividend will be placed inside the division symbol. Notice that I do not have an x term, so I will place a 0x in its place. Now place the divisor of x minus 0 on the outside of our division symbol. Now we are ready to divide. I like to divide by asking the multiplication question, x times what will give me 3x cubed? We can see that 3x squared times x will give us 3x cubed. So I will write 3x squared in the quotient above the x squared term, and then multiply 3x squared times the divisor of x minus 4, and get 3x cubed minus 12x squared. Notice how I lined up the like terms so that the subtraction will be easier to do. Now when we subtract, we need to subtract both of the terms, so I tell my students to change the sign and change the sign and then add. Doing this will result in no more x cubed terms, a positive 11x squared, and now I bring down my 0x term and divide again. X times what will give me 11x squared? This will be 11x. I write 11x in the quotient above the 0x term, then multiply 11x times x minus 4, and I get 11x squared minus 44x. Change the sign, and add like terms. This will give us 44x We bring down the negative 150 and divide again. X times what will give me 44x? Write 44 in the quotient and multiply 44 times x minus 4 and get 44x minus 176. Change the sign, and add like terms. We find that we have a remainder of 26. This means that we can write our polynomial of 3x cubed minus x squared minus 150 as our quotient, which is 3x squared plus 11x plus 44, times our divisor, which was x minus 4, plus our remainder of 26. So you want an easier way of dividing polynomials? We do have an easier way, but it is very limited. We can use synthetic division when we want to divide polynomials by a divisor that is in the form of x minus some number a. So let's do the same problem of 3x cubed minus x squared minus 150 divided by x minus 4. But use synthetic division as it meets the requirement for the divisor that is in the form of x minus a number.